Do
When
we get any mock questions before the OPPA?
Mock, I can provide you some to practice, but yeah, that you can just think of as that type of questions only will be asked. See, whatever we are practicing, those only will be asked, like the same question itself. The same, I mean, might be the data set will be changed and then here and there. But whatever we like for whatever we have done it in this 7 8 hours, that only will be asked. Okay, not even more than that. Not like yeah. So this will be asked. I hope this makes it.
Um,
Yeah, that's okay.
During
So we will be
OPP,
asked.
like, we'll be given one problem or multiple problems,
You'll be given multiple problems.
and we
Multiple
can.
problems. You mean
Sorry.
yeah? Let's for example, you'll be asked regarding any of the NumPy module. Like from the NumPy itself, you'll be given a matrices. Okay, and then you'll be asked what is the dimension. Okay, so there you'll have to use the Colab and then write the answer in your like on the portal. Okay, this type of problems will be there.
Okay, so the coding part we can do in collaborative.
Like for example, in SVM, you'll be asked to use the or maybe use the perceptron concept and then find the W. Okay, the data set
So
will be given.
this
The
is
data set will be
sort of like the ROE in TDS.
RO in TDS. TDS. Sorry, I'm not aware of that.
Oh,
But
okay. So
Is there any multiple choice questions?
no
OPPA?
multiple choice question. All of those will be NAT only. NAT is like
Just could you please share mock as soon as possible so that we can
I will
practice?
try to uh, maybe upload on the same drive by tomorrow, but I can't promise it. But
Okay,
I'll
sir.
totally
Thank you.
try to because mock will be almost the similar to OPP itself. So yeah, so I'll try to then also I'll try to at least put some questions. Maybe OPP it will be asked around 20 questions will be there. I'll try to put it in the mock 10 questions around that. That will help you. Okay,
and
PYQs, either? We have any
that
PYQs?
will be a proctor exam. Yeah.
No, no, no.
And
Previous
documentation
year,
will be mode.
previous year questions will you be giving
What?
us? Previous year question papers.
Yeah, previous year question I don't have. If somebody would have written, they must be having that. But we don't have it. Like I don't have it. Okay, I'll try to put it, but yeah, I can't promise it. Like I'll have to check with the person who was taking earlier. Yeah.
Okay.
so we
Hmm.
need to practice a collab, right? The collab we will be providing all the solution and
Yeah.
all.
Only those collab that we have done is more than enough.
More than
Whatever
enough
we
for that.
have done is more than enough. Yeah.
Okay,
Nothing
thanks.
more than that will be asked.
Okay.
Okay. Any whatever algorithm we have taught, those only will be asked. We will not be asking anything from decision tree or anything else. Just the model that we have discussed. Regression we have discussed, K-mean and then SPM.
Okay. So I
Mean
will
and the
simply
basic about the NumPy. That's it.
okay. So I will simply understand that collab and all. Whatever doubt is there, I will ask, and only that one will be asking.
Correct.
Okay.
Yeah.
Thank.
Hmm. Okay. So what I was trying to say, yeah, perceptron. I hope you are aware of the concept, right? What we used to do in the perceptron. Anybody?
Neural neural networks. You know.
Okay. So in the perceptron that we have read in MLT course, what we were doing? Can somebody just speak out and tell me?
Sir, we had
So we were projecting the data point onto the weight vector and then finding the signum function of it and then comparing with the actual label of it.
No, no, separating two classes.
Okay. Yeah.
The
So
linearly separable data, we were trying to find the
correct.
linear boundary to between two classes. W transpose xi is greater than 0.
Yeah. So we were just using a loop, something like that, and then we were checking. We were what we were doing if we have a linearly separable. I am not going to going in. I'll not be going in deep to tell you. I'll just go in a glance so that whatever I'll be doing will be able to understand that. That is my motive for today. So in the perceptron, if you have a linearly separable data set, And then if you have a linearly separable data set, you are able, because it's a classification problem, right? So we need a hyperplane that will differentiate two categories of the data set, right? So what we have done, the very basic model was our perceptron, right? What we were doing, we were just checking, okay, if just taking care of each of the data set, each of the data point we were taking, okay, and then we were doing something, right? W transpose X, and if it is in the positive direction, if greater than 0, then we were thinking, okay, so this data set should be in the positive direction, okay. And then if a data set we were doing the W transpose X, or we were just checking in which direction of that hyperplane is the data lying, right? This is what we were doing. And if the data set, like the predicted, that whatever we are predicting and whatever has been given is different, then we were updating the W value, right? This is what we were doing in the perceptron. This is pretty simple, right? And what was the updated rule? Can somebody tell me how we were updating the rule? W plus something we were doing, right?
XIY.
Correct. So this is what we were doing in the perceptron, nothing more, nothing less, right? So this was perceptron. But we came to know that we were checking whether it will converge or not. Then we came across something, right? Then our assumption, we just change it. Like we change it, like if we have a linearly separable data with some gamma margin, right? And if with some radius and all those things we have already seen, then we came to know that it can make a maximum of some number of mistake it can make, that will be directly proportional to some r square upon gamma square, right? Then we came to conclude that it will converge, because the number of mistake, if we are able to get for any algorithm the number of convergence, like number of data point that a model can do a mistake, then that means it will converge for sure, right? So in the perceptron model, we can have a n number of hyperplane, right? So you can see that a green and a red data point, right? These are totally linearly separable, and we have a good gamma also, gamma margin. And then we can have an infinite number of valid linear classifier you can get. You can see that two of them is represented here. You can just think of 3 itself, right? So you can directly see it, right? Now the perceptron model generally returns a valid classifier, a linear classifier, okay. Now the one question is it a best, is it a good one? So for that, we'll have to go across where to the support vector machine, right? So support for the perceptron is what? Perceptron, you can just think of as the initial part of the SVM, where in the perceptron, for the data set which were linearly classic, like linearly separable data set, if you have, okay, you were able to find a hyperplane, right? With a very simple, if a data set is correctly classified, that's fine. If not, then you were updating the W, right? And then you were doing it for all the data point, and in the end, you were checking, okay? After doing for whole data point, you came across a W, right? And then you were checking again whether all of the data point is satisfied with that hyperplane or not. If it is satisfied, then that hyperplane became your that will be your linearly classifier, right? That hyperplane will become your classifier. If it is not, then again you'll be keep on updating, and at the end of the day, you'll for sure get a classifier, okay, in a perceptron. But we moved toward the SVM. Then we started searching for, is the data set, whatever we have, the linearly separable data, has some margin or not, some gamma margin or not. If they have a gamma margin, then what we were trying to do, we started doing maximizing our gamma, right? If we'll maximize our gamma, then what will happen? If we have a hyperplane with a maximum gamma margin, then we came across that those type of a hyperplane were much more, having very less number of mistakes they were making, because we have already seen that in the perceptron also, the number of mistake that will making it dependent on what, 1 upon gamma square, right? If your gamma, that is the margin, is more, right, it will do a less number of mistake, right? This is what it means. If you have some relation where if the number of mistake is proportional, like, or inversely proportional to 1 upon gamma square. This is what it means. You can see here, okay, this and all we are not going to discuss. Then for the support vector machine, what we did, we started maximizing our margin. So you can just calculate the margin and then try to maximize that, right? And there was a formula that you would have got 2 upon W, right? Or 1 upon W, some will say 2 upon W and 1 upon that will not make any difference, because if you have to maximize something 2 upon W or some constant upon W, okay, what we were trying to do, we were trying to minimize W square upon 2, right? Because that becomes a quadratic equation, and that is simpler for us to minimize any function than to maximize. Okay, and will come to know that also in the SciPy that we'll be using, one of the library that we'll be using, we'll be getting a minimization function itself. There we can just give a function that the minimize function in the SciPy library will give us the exact argmax or that particular point where the function is getting minimized. We'll see that. Okay, so as of now, I'm just giving you a basic idea about the SVM, so that well, when we'll be doing the coding part, you'll not get will not be a bouncer. Okay, so again, the same thing, we were maximizing. You can see that we were trying to maximize the 1 upon W, that is the width or the gamma, you can think, or you minimize W square upon 2. Both are same, right? Because we don't worry about the exact maximum value. We are just worrying about the point at which it is getting maximized or minimized. Okay, so that if we are just worrying about the point at which it is getting maximized or minimized, we don't have to worry about that. Okay, whether we are doing it for 1 upon W or W square upon 2. I hope that is making sense. And then we have some constant also. So what are the constant? If you have n number of data points, we'll be having n constant, right? Because each of the data points should lie in the correct direction, right? We are all discussing about the hard margin as of now. We'll see the soft margin also. So these are the constant. N number of constants will be there because n number of data points you have. So all those data points should lie on the correct direction, right? So these are our problem, right? This is our primal equation where you have to minimize some function subject to some constant that has been given. Then you use the Lagrange concept, and then you came across something min-max problem. You'll be coming across a min-max problem, and then that becomes a max-min problem that you already know with the help of strong duality. This becomes the right side is the dual problem, and then after solving, we'll come across a very nice equation. Okay, this is the nice equation. You have this is equation, right? That what we have to do, we have to maximize some equation alpha transpose 1 minus alpha transpose the y transpose x transpose xy times alpha upon 2. This is the function that we'll be using directly today, and with the help of the SciPy, we'll calculate that alpha at which this function is getting maximized. And alpha, if you are aware, if you can remember the SVM, alpha was for each data point you are having some alpha, right? The contribution that it is giving, right? This is what alpha was, right? I hope you are already know about this concept, right?
Yes, 0 to C, alpha to C, and something like that.
0 to C was for the soft margin, right? But for the hard, you can
Yeah.
have any values, right?
Sir, alpha plus beta
as far as I remember, these alpha is the Lagrange multipliers, right?
Yeah, that's where the Lagrange multiplier, or you can see that if you'll just the upper, if you'll see W equals to XY times alpha, right? So alpha was for each of the data points, you'll get some alpha. The contribution is making the hyperplane, because you can see that, right? XY alpha. It's like the combination of XY alpha, right? So here, if you are getting for some data point, you can have so this is like a sparse vector where most of the values will be for most of the data point, there won't be much contribution to get your hyperplane. Okay, very less number of data point will be there that will contribute in your hyperplane, and those data set are what? Support vector, right? Are you aware of that? You already know that, right? For all those values, all those vectors where you'll be getting some alpha value, those are the vector that will support in giving you your hyperplane, that is W, right? And all those vectors where alpha will be 0, those are what? Those are not the supporting, they are non-supporting. Even though if you have a data set with just those points, we have some alpha value except 0, will give you the same hyperplane as you have an n number of data point with alpha equals to 0, like non-supporting vectors. Okay, I hope that is clear. So let's go to we'll try to write the code. Okay,
Sir, we also have alpha plus beta equal to C, right?
alpha plus beta will come across when we'll be dealing with the soft
Margin.
SVM. Okay, where we'll be dealing with the penalty and all, right? Here in hard margin, we'll just be going through where you have a linearly separable data set. There is no data set that is lying in the other direction, right? All the data set are linearly separable, right? So here we don't have to worry about those cases, right?
Okay, sir.
The SVM will see that in SC will be using the code will be almost same for SVM. Only the condition in the SVM will be what? You can see that. See, the dual problem in the hard margin is what? Where the alpha can be any value. greater than 0. Okay, the Lagrange value that you are Lagrange coefficient, right? Or the contribution of each of the data point toward the making the hyperplane. But in the soft margin, if you'll see that, you'll just be having one the alpha value, there will be some restriction, and that restriction is what the value of alpha will be from 0 to c. That is what will happen. I hope, I don't know where is that equation, but yeah, we'll come across that also. Let's start. I hope we have already gave you okay, this is, let's deal with that.
Sir, can you share the slide which you were showing now in Drive?
In the drive, I'll share that. I'll share that. But
Okay,
once
sir.
the session got finished, then only, right? Or you want now?
Later we can share, sir. Yes.
Okay.
You can find in chat also. There is a link.
I guess that is different.
Okay, Priyanshu Sharma, right?
That's a whole PDF actually.
Okay. So let's start with the SVM now. So the first thing that we'll have to import all those things, right? Again, at least the numpy and the matplotlib, because we'll have to plot. We have to see the hyperplane also. So we'll just import the imported. We already know that as np. What
Sir,
else we
have you
need?
shared the collab link?
Collab link I have not shared. You want this collab link?
Yeah, it would be easier to just code along.
Okay, okay. Wait, just wait a minute. I'll just share it now, sir.
Sure, sir.
So could you also share the YouTube जहाँ पे recordings save हो रही है वो link?
Recording. Yeah. Okay. So recording, I'll be uploading after the session. Okay, and then I'll share you the whole 4 days of videos itself. Okay.
So
Okay.
recording is live streaming in the YouTube channel, no? That in
Yeah,
the
exactly.
It's not
yeah.
live stream today. Yeah. See
Oh.
this. Till now I was doing that, but today I just got information that we'll have to upload and share it in the. So I was not aware of that. So that's why we'll be uploading this today itself. Okay, after the session will get finished and upload it, all the 4 video, and then we'll share with you in the same the G space that we have. Okay, and we'll make the private also, so that will be done, but not today. Might be tomorrow.
So I've shared in the chat if you can access.
Okay, so collab you have already shared.
Yes, sir, in the chat.
Okay. Then everybody can see that, right?
Yes, thank you. Thank you, everybody.
Yeah.
Okay, I'll also do in the same file that you have shared. So we can do it in the same. Maybe I'll make a copy of this and then. You're able to see my screen, right?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, so one thing I'll just copy it is the data set, because this is the data set on which we'll be working on. Okay, and now I'll just install. You already know that what we have to install. Like we have to import some of the important libraries, numpy for sure as np, and then we have to import matplotlib, matplotlib.pyplot. Okay, so I'll just install this. Yeah.
Sir, can you please paste this dataset on chat? I don't
Which
think the shared link has it.
what I didn't. Okay, you want to zoom that?
No, sir. The dataset in the. Can you please paste the dataset in the chat?
Okay, you want the data set. Okay.
Thank you, sir.
Okay. Is it visible? The screen, the font is fine now.
Yeah.
Yes, sir.
Fine.
Okay. So we have installed. Now we'll see that what is the data. So we have taken the data set. Now if you want to see the data set itself, this is X, right? So you can see the X is okay. What is the shape of X? Can somebody tell me the shape? What will be the shape? It will be 2 cross. What is the number that we have given? Okay, let's see it. So we have given 20 data set, right? So now the shape is 2 cross 20. So 2 is the number of feature. Okay, because we are using the whole MLT, we have used D cross N, right? Where D is the number of features and N is the number of data set that we have, correct? So in this way only we are using. Now you can see for the Y also, if I'll just add some. Y also, if you'll just see, or Y shape also, we have 20. It should be 20 cross. So it should be a tuple with 20 data set, correct? So we have two features, 20 data point. I hope this is clear. Now we'll try to visualize the data set. Yeah.
Just a small doubt. So we are calculating the dimension. So dimension is equal to a number of features, like equals to D, right? Or
Okay. So one more thing. From the starting, I'm telling you, right? Like everyone, whenever see X is in the form of some matrix form, right? So if a data set is in the form of a matrix, then it will be a 2 dimension every time, whether it's a 1000 cross 1000 or whatever. In NumPy, it will take a 2 dimension only. If you are dealing with a vector, that will be a 1 dimension. So it will always be giving you 1 dimension. But here, the shape is not the dimension. Shape is a different thing. Shape is just telling you what is the rows across column for a matrix that we are dealing. For X, it's 2 cross 20. Okay, so we have 2 rows and 20 column. So each column is a new data set, right? That we already know. Correct? It's a D cross N. So D is the number of features. So 2 features. Let's say example 1 minus 3. It can be something, weight of a person, and minus 3 maybe how much rent he has to pay. Okay, so 3 rupees, something like that. Okay, so 2 feature for first data points. Similarly, for the second data point, we have 1 cross minus 1 minus 2. Third one, 4 3. Okay, in this way. Is it clear?
So, it should be 1 minus 3 1 0, right? I mean, 4 1 3 7,
What?
because 1 minus 3, that's just the first row, right? And
No, see. Okay, one more thing. How can this be a first row? So we are taking whenever we were defining X, we have taken the transpose itself in the starting. So if you had
okay,
you
right,
got it,
right,
right?
right.
So the data set is in the form of D cross N. D cross N. So 2 rows, 20 column.
Yeah, still. So no. That's not what I was saying. You could just scroll down a bit. I mean, this is a little miscommunication. You were just so we have 4 lines here, right? So the second line is just the first row wrapped in the second line. So my
Yeah,
data
that's
point.
why. Okay, got it. Okay, yeah. The
Yeah,
second 1 0 4 1. Yeah, correct.
yeah.
1 minus 3. Yeah, that's the first row, and the second row is then the down one.
Right. That's why I got a little confused. Anyway, yeah.
Let's see it from here also. This is 1 0. So if you'll just transpose it, it will go down 4 1 3 7, right? I don't
sir,
explain or interpreting. Yeah.
I asked for X for dime, that one. Shape I know. The dime, like your dimension is 2 only for matrix and 1 for vector. X dot
Yeah.
dime, right?
For vector, it is 1 always. Okay. And for a matrix, it will always be 2. So for a
Okay.
vector, and dimension will always be. So NumPy take everything in the form of a n-dimensional array. Okay, so if you have a
Okay.
single dimensional array, it's a vector. If it's a two-dimensional array, it's a matrix. Because to write a matrix, you already know how do you write a matrix. You start from
Double.
up and down and then go from left to right. That means you are in a writing in the form of a table, right? Table in two direction, up to down, left to right. But in a vector, you write either from left to right or from up to down. Nothing else, right?
Yes, sir.
Yeah, so that's why. Okay, if I have to visualize the data set, right? I have to visualize the data set, and then what has been said, let us now visualize the data set given to us using a scatter plot. So scatter plot we have already gone through, right? PLT dot scatter, right? You do something like that, and then you put x comma y, right? We'll see that what, okay. So if you have to represent this data set, right? If you have to represent something 1 comma minus 3, 1 comma 0, 4 comma 1, 3 comma, so you'll have to put the x and the y, right? To if you have to how generally we used to represent, we need a x and a y, correct? How can I extract x from this value? How can I extract 1 1 4 3? How can I extract that?
X0, sir. X0.
X0.
I need, so the row should be 0, right? Column can be anything, right?
Yes.
Are we getting a point? So this will be our x, right? And then similarly, the next should be what? The next should be the next row. That means the first row, correct? And the column can be anything.
First row and column can be anything.
Correct? If I'll just plot this, it should give us something, right? See, you can see that, right? For any data set, if you have to just plot it in the form of a dot, what do you need? X and Y coordinate. So this is what I have given, the X coordinate and the Y coordinate. Are there? Are you able to understand this?
So you used both the X, you didn't use Y, I think.
No, Y we don't have to use, right? This is our Y. See,
Okay,
if you
okay,
have to
okay.
plot, let's for example, you have to plot 1 comma minus 3. What should be your X 1, right? What should be your Y minus 3? How do you represent
Okay,
any point,
okay.
any vector 1 comma 2? Because in that 1 becomes your X point and 2 becomes your Y point, correct?
Yeah, right.
So in that way, they have represented. But the thing is, we have been said that we'll color point which belongs to class +1 for the green, and those belongs to -1 should be red. Okay, but now whatever we have plotted, everything is blue. Then we'll have to do something, right? So let's see, we'll be using one function. So I'll just y the color should be equals to np. We'll be using np where I don't, okay, if you don't know, I'll just put it np where. So it's like what? Okay. So np where, if you just read about the np where, you'll have to apply a condition. Okay, if it satisfies that condition, it will hold something, and if it doesn't, then it will hold something else. Okay, if you'll just read through somewhere, if it is given. So okay, yeah. So if np dot where a less than -4, then represent it as a or -1. I'll just represent here. That will help you to understand more. I am just defining one color, y color, because we have to plot it, right? We have to visualize those all data point, because we should be knowing, right? Where is the one category, where is the other category, -1 wala category, and where is the +1 wala category. Okay, then only we'll be able to see whether the data point are linearly separable with some hyperplane or not. For that, we'll have to give some different color. Okay, whatever we have for the 20 data point, okay, we'll have to represent with the help of two different color. So now to have a two different color, what I'll be doing, so there's a function np.where, what it'll take some condition, okay, where y equals to 1. Whenever y is equals to 1, okay, this y is what? The label that we were having. So that label we were having, right? Something. So this label, correct? One label for the first data point, say 1 for the second data point. You can see that in the starting 10 data point, it has taken 1 as a label. And the in 10 data point, it has given -1 as a label. Okay, so what I'll be doing, wherever y is equals to 1, okay, I'll be giving green color. Okay, otherwise red color. Okay, and then we'll try to see that whether for each of, I'll see that whether I'll just print y, and I'll print the color also. So corresponding to which y, which color has been assigned. Let's see. You can see that starting 10 values, wherever the y was 1, 1, 1, so all the green thing has been assigned, right? You can see that, right? The starting 10, if you'll just count it out, the 10 values will be green and the later 10 will be red because we have given some condition. So this is a np dot where, okay, is a function in the numpy itself where this is the condition. If it satisfies this condition, give it green, or if it doesn't, then give it red. I hope this is making sense. Then we'll try to plot. Okay, let's plot it. We'll copy the same code. We just have to give what? The color, right? If you'll just give the color itself, C is equals to Y underscore color. Now we'll give some, you can see that, right? Now we have a different color. Now we'll just give a axis and all everything that will, are there? Are you guys here? Are you able to understand this? Okay.
Yes, sir. This is clear.
Yes, sir. So this axis and all, you can just give it or just write it down.
What is C doing basically?
We are just giving that color, right? Y color, right? Y underscore color.
So C is like a property that you're using, like
In the
in
scatter
example.
plot, yeah. So in the scatter plot, it's there. You just give X, Y, and then there are n number of things that you can give in the scatter plot.
Right.
Okay, so we are giving the color.
C is for color only.
So here we are just defining the Y underscore color. So that's why we have just given. If you just want to read more, what you can do is plt dot scatter. Just do it underscore and read it. So if you just read it here, there are n number of things like that you can give it out. For example, color type you can give, or many things you can give it. Is color, so many other things you can give it out. So we have just given the color. Okay.
Yeah.
So now we'll add the. If you want to add, you can just add it out. Here also we'll give the. Okay, so we'll just give the color as black as a horizontal line, and for the vertical line also we'll give a black color, right? AXV line that we have already read about this color equals to black. If you want to give something else also, maybe the line style, you can give the line style also. Is it the line style, the one we are talking about? Style. The same thing, you can give it for the horizontal line also. And then it will just, okay. You can see that. Now, can somebody tell me whether this red and blue or the green point is linearly separable by just seeing it?
Yes, sir.
No, sir. Like there are some point which is which are lying green and red, so we cannot separate that.
Why can't we separate? If a line almost around y equals to x axis, y equals to x, if you just see that, you can get a line, right? That will separate a green, the red one and the blue one, the whatever the green one, right? A line that is passing through like this will
Oh
separate,
yes,
right?
y equal to x can separate. Yes, yes.
Yeah, no, I'm
I
just
can
asking
think.
you a plane, right? That will separate it.
Yes,
Sir,
yes.
what is the purpose of line you have given?
Which line? This is
Horizontal
horizontal and
and vertical.
vertical line. This is a horizontal, your
Okay.
x-axis and y-axis. Okay.
Okay,
Okay.
okay.
If I'll just,
Sounds here.
let's for example, I'm just removing that. If you are getting confused with that. Now this, you'll be able to get, right. But why did I put it like this? Because mostly we are reading about those hyperplane only, which are passing through origin. We are not reading about any other hyperplane, right? shifting and all we have not read it in the codes. We are just read it about those hyperplane which are we don't those doesn't have any bias. Okay, mostly a hyperplane has some bias that you write it in W transpose X plus B, but we are just reading about those hyperplane. Those are in the form of W transpose X that passes through our origin. So 0, 0 should satisfy. So as 0, 0 through 0, 0, you can find a hyperplane, right? That will separate these two, and we'll see that we'll use the perceptron. Okay, let's to deal with that, to check whether we are able to find or we are able to find a hyperplane, that will use the concept of the perceptron, and whether we are able to find some hyperplane or not. So we'll have to do something, right? We'll have to use the concept of perceptron. Till now, is it clear, right? Everything?
Yes.
Okay. So
Yes,
for the
sir.
perceptron, what did I say? For the perceptron, you do something, right? You apply some loop, right? You go through each of the data point and then check whether it is in the correct direction or not. If it is in the correct direction, you give some value. You predict it as 1, right? And how do you check whether it's in the positive direction? You do something, W transpose X, right? That is what you used to do. And if that is in the correct, if any data point whose value W transpose X is positive, you just think that this should be the Y predicted should be 1, right? Or else the -1. Correct? You do it for each of the data point. And whenever the predicted value that you got for any of the data point is equals to the data point that has been already, the label that has already been given, then you don't do anything. But if a predicted that you have predicted, okay, you see what happens in the perceptron. You start with some zero, like hyperplane, right? You initiate with something. Initiate with 0, 0. Will initiate with 0, 0, right? That will be your hyperplane 0, 0. Now you will check with 0, 0 itself for all the data point, and for whichever the data point you will, with that data point you will see that okay, if W transpose X is greater than 0, then the predicted value should be 1, and if it is not, then it should be -1, right? You go through each of the data point. But let's, for example, for some data point you found that the predicted value that you got, it's not equal to the label that was given earlier. Then you do some updation, right? You want to go in that direction where whatever the hyperplane that you'll be getting in the next iteration, that should satisfy the condition of Y predicted should be equals to the Y label that has been given to you earlier, right? This is what you want in the perceptron. And then you keep on doing that, and at the end of the day, it will converge toward a hyperplane that will, for each of the data point, it will satisfy. It will, the Y predicted will come out to be equal to your Y label, and then that will become your perceptron, the linear classifier. Okay, I hope that is clear. So let's try to write it out. So we'll start with, what did I say? NP dot zeros, right? NP dot zeros, what it does? And what should I write here? D or N? What should I write here?
N, sir.
Somebody tell?
D.
D,
X
D,
dot
sir.
shape 0.
Correct. So I should be writing D here. So I started with this. Okay. Now I'll have to apply some for loop. What for I in, and I have to go through how many times the number of data point that is available there. Correct? What should I do? The Y predicted that I'll do, the prediction of each of the data point is equals to 1 for which all courses, if what will happen if the W transpose X. So should I write transpose or can I write the W directly? Should I write the transpose or should I use that at the rate directly? The dot
W
product, for the dot
transpose.
product we used to use, right?
That directly.
Directly,
Oh,
because
directly. Yeah.
use a vector, right?
Automatically will
And
do.
it will adjust itself. Even though you write W trans like dot T, that's not going to do anything, like, because for a vector you already know that in the numpy it will adjust itself, right? You don't have to do for a vector to transpose, like you already know that it will not do anything. So it's better you can directly use the same vector W itself, W transpose X. So what should I write here? Again the same thing, it should take the whole thing from the row, okay, and I, like for each. So what I'm trying to do here, see, I just applied a loop here, and it should run for how many times? Like for all the data point, right? So it will start from I till n. So n is the number of data points. So here it should run 20 times. Then what should it do? Y predicted should be equals to 1 if the W transpose X value for any of the data point, and any of the data point will be what? I can take all the row with I as a column. So I is a column means ith data point, right? Ith data point, row, all the row I'm taking. That means this becomes a single data point, ith data point, right? And W transpose X, if it is greater than equals to 0, else it should give -1. So now Y predicted will take 1 whenever that particular point or W transpose X is coming out to be greater than equals to 0. It will give the Y predicted for that particular data point as 1. And if it is not, W transpose X is not equals greater than equals to 0, then it will give a -1. Are you there? Able to understand
Yes,
this,
sir.
right?
Yes,
Yes,
sir.
sir.
Okay. Now what will I do?
Sir,
So
this if and else condition we can write this because of this collab, or in same line we are writing it.
yeah, we can write it, right? No problem. So what I'm checking, if Y predicted is 1, okay, when if W transpose is greater than equals to 0, else what should be the value of Y predicted? -1.
So I think what he is asking, it is a functional programming style in Python.
Yeah,
It is
Yeah,
Python
allowed.
style.
Yes, like I think in Python it's not allowed. Is it? Or because of collab we are using it?
No, I think it allows.
it allowed everywhere. Like
It's allowed.
Python, you can just write it like this, right?
It is allowed.
I mean, we can write multiple lines of if-else code, right? I mean, it's not necessary to write it in a single line. That's what you're asking.
Yeah, there is a style.
Yes.
You can't just like the way you wish, but yeah.
Single if
Okay.
else command is allowed. It's Python style.
Yes, allowed. Right.
Okay. Now,
Okay, fine,
what
fine.
should I do? I told you for the perceptron, you have to go through this loop, right? For each of the data point. Now, you have given the Y predicted value, okay, as 1 if it is in the correct direction, and -1 if it's not in the correct direction. Now, what should I do? I'll have to check something, right? What should I check? Whether the predicted value for each of the data point is equals to the label that was given earlier or not. If it is not equal, then we'll have to update W, right? Otherwise, we don't have to do anything. So I'll have to check something, right? Now, what should I do? In the same loop, because we're doing in the same loop, right? Now, first I
Sir,
check
would
data.
it be Sir, would
Yeah.
it be better like if we store the Y predicted in an array basically?
So how does that help?
So like we'll get an idea like just to store the Y predicted in an array or a list maybe. So like if we want to use the Y predicted values later so that we can compare with the actual Y that we had and what we predicted to find the loss and stuff.
Yeah. So, but it is storing, right? Y predicted is storing according to each of the data point, right?
But sir, it's not storing as an array, right?
No, so the thing is
See,
that this is not our final prediction, right? So yeah, in each iteration, it might possibly change. So there is no point in just looking at the Y pred at every iteration. I guess we could do it, but
We don't want to store Y predict, right? We just want for this calculation only.
yeah, see what is, we have to just check, okay, for like first data point I took, right? And then I have to just check at that particular time, right? That Y predicted that I have got it from that W which with which we have initialized, right? Whether that is equals to the label that is present earlier or not. This is what we have to do, nothing else, right? See, next time
Okay,
I
okay, sir, got it, sir, got it.
got it, right? If this is not equals to what, the Y that I already have, correct? If it's not equals to this, then what should I do? I'll have to do something, right? I'll have to update the W, correct? And what should be the value of the W? W plus
XIYI.
IX, right? Correct? X
Sir,
times.
here n is the number of data points, right? And
Correct.
d is the number of features. Is it d?
D is the number of features. Yeah.
Okay,
We are
okay,
dealing with only 2 features, right?
okay, got it. Yeah.
Yeah. This is what we have to do. I hope this is making sense. So whenever it's not equals to y predicted, if the y that we have got is not equals to whatever the label that has already assigned in the starting, if both are not equal, then we'll update the value of our hyperplane. If it's there, then we'll not update the hyperplane. Correct? Is it clear to everyone?
Yes, sir.
Clear, right? Okay.
Yes, sir.
Now, what should I do?
Else,
What is the next step?
Do nothing.
No.
We do the loop again.
Okay. So see, this loop will get finished, right? Okay. So this will perform. So this will perform once, right? Now, what else we have to do? If it will, so one cycle will be done, right? Now we have to compare something, right?
We have to check if the
Y prediction.
predicted if I
Correct.
predicted is same as the
Correct.
original one,
Correct. Yeah.
and
We'll
then
have to
again we
check
will
that,
multiply.
right? Yeah. Yeah. So for that, we'll have to come out of this loop, right? Are you able to understand this? We'll have to come out of this loop. So we'll have to go there. We'll have to come out of this, and then we'll have to check the y predicted that we have got. Y predicted that we have got. Again, we can use the same thing. NP where. What should I write? If yeah, y predicted. It should be C. Okay, so till now what we have done, we have okay, so we have started with something, and then we have so in the perceptron you iterate it from first point and you give some predicted value, and if it is coming out to be true, that is fine. Else and okay, so we have updated it. Yeah, so one loop has been done. Okay, so that finished, the full cycle has been done. Okay, now what I have to do, I'll have to check whether predicted value that we have got is with all the x I have to check now is equals greater than equals to. If it is satisfying this, it should be 1, otherwise it should be -1. Are you able to understand this, or should I try it something somehow other method? Okay,
So this
so
np dot where returns an array, right?
yeah, it will return an array. Because we are doing it for all the data point, right?
Yes, yes, yes. So actually, this is what I was telling. So I like
Oh, okay,
this
okay.
we need to do after the for loop actually.
Correct. And
Okay.
then
No,
we'll have
sir.
to yeah.
In the last line of code you have written, here we are trying to check whether all the data points are correctly classified or not.
Correct. So because we have done one full cycle, right? After that, we'll have to check something, right? For whatever the
We need to check
predictor
it.
that we have got. Okay. Now we have to compare,
Is
right?
it
So next step should
is it
be
same or
we'll
not?
have to compare. Yeah. Now we'll have to compare. So to compare, we can use this, right? NP. Yeah. This one we can use it and compare if it is same. The label of y predictor that we have got for each of the data points, for all the data points, if it is same, then we can ask them to return something. Are you there? Maybe let's for example some return, so that I'll just if it is see, let's for example y predictor that we have got and y. If it is coming out to be same, we should ask something to return. Maybe let's for example this converged. The data set that we have converged and we got some hyperplane, right? Converged. And then it should come out of that loop. Okay. Is there any confusion in this as of now?
Sir, finally, we also need that W, final W.
No. One more thing we have to do. See, let's for example, we are just applying this converged equals to true. That means it should go inside some loop. It should start with converged equals to false, so that it should go inside some loop, right? Maybe while loop we can apply inside, and then inside that while loop, okay. So because if we are just, it should break. Like, see, there should be something that should break, right? If the converge equals to true, that means we are getting some hyperplane, right? It should break, and then at the end of the day, we should get some hyperplane. So we can start it something like uh, converge equals to, let's for example, false.
So it should be capital, start with capital C, converged.
Converge, yeah, it should start with converge, should be false, so that it should go enter some loop, and that
Capital
loop
C,
can we can use while loop, right?
variable name, sir.
The variable name you are using two different places. So
Where?
below you have used capital
Okay,
C.
one
Converge.
sorry, sir. Converge. We'll have to. So now we are going inside. So we have started with, so the function, in the starting it was not converse. We have started with some random w initialized, and then we go on inside the, it was a false state. It was not correct, so we went inside, and then we applied the whole for our cycle. Okay, so we checked with for all the data point. Then we checked whether after coming out the y predicted is equals to, like, it's satisfied, and then y predicted we got it 1 or -1 according to whether in which, where it is lying. Like, we got some w because after updating after n number of cycle we would have got some w, and after getting that w we are checking, calculating basically the y predict, the array. Okay, and then we are checking whether that predicted value and the y value that we were having earlier is same or not, and if it is same, then we have to come out like of the loop. Okay, and that is what our w is, right? Are you there? Are you able to understand this or not? Or maybe
Sir, Y predicted and Y both are arrays, right?
both are arrays, right?
So all
See,
the
why
elements
predicted that
inside.
we got, see, it should have returned some array for all the data points, because that's why we are checking for all the x, each of the data point, right? And
Yes.
why we would have, see what it is happening here. So why after finishing this loop, it would have came out with some w, right? And for that w we are checking, right, whether the y, we would have got some array like y predicted, and that predicted value should be equals to our the initial y label that has been given in the starting here.
1 1 like this.
Yeah,
So all the elements inside Y predicted must match with a Y.
correct.
Okay.
Must match with not one, with the label of the y,
A
not with
label means if it's 1, then it must match with 1. If it's 0, it must match with 0. Like that.
-1. Yeah, correct.
-1.
Yeah, even the one like difference, and it will give you something like, so let's say example, screen is visible, right?
Sir, but I don't get the point of using a while loop here. Like, I think it's not required.
Which one?
So
No,
the
no.
while
Why
loop
did
should
we
be-
use? Okay, I'll tell you why did we use the while loop. See, this was the first cycle, right? Perceptron. This is the first cycle, correct?
Yes, sir.
First, after first cycle, we would have got some w, right? Some hyperplane
Yes,
you
sir.
got.
Yes,
Okay.
sir.
With that hyperplane, you'll have to calculate the predicted label, right? Whether to check whether all the data point are correctly classified or not.
Yes, sir.
Okay. If it is correctly classified, then why will you move in and around? You'll have to come out, right? So this, we have to apply some loop, right? While loop, so that converts, like, it will give you the information that you have got your you are the hyperplane that you have got is converged. Now you can come out of that loop, not this loop, the whole loop. Oh, sorry, what happened?
Control Z, Control Z.
I don't know, control's not working.
Hi.
Okay. Yeah. Have you understood or not? See, this is why I just applied another loop, because this was the first cycle. After the first cycle, it would have gone through each of the data point, but each of the, even though it would have gone through each of the data point, whatever the W that you have got, the hyperplane you would have got something. Maybe that hyperplane will not work, and then you'll have to go inside the loop again and then come out again with some W. But if your W is correct, like the final value, the W that you have got is linear classifier, and it's working for whole data set, then you have to come out, right? You can't be moving in and around. Are you getting
Yes, sir,
or
got
not?
it. Yes, sir, got it, got it.
Got it, right? Because the converge will become true, and then it will not go inside this loop. Everybody understood this or not?
Sir, just one need to ask one thing.
So
We
let's check
are
we are getting some W or okay, some mistake we are doing. Oh,
D is not defined as red.
So use x dot shape 0, so instead D.
D, sir. NP dot 0 is D.
maybe you can write 2 directly, right? Because we are having 2. Okay.
So even n is not defined.
For I in range N.
What?
For
Sir,
I
you
in
can just write d comma n equal to x dot shape. Then it will
The
work.
fourth line, sir.
No. Fourth line N.
Yeah, we can use
20,
directly,
sir,
right?
20.
It can work. No, x dot shape won't work, right?
No, sir. In the starting only, if you write d comma n equal to x dot shape, then it will already like give us the value of d
Okay,
and n.
yeah. One thing you can do in the starting itself, right? Whatever you have said is correct. You can just write it as d comma n equals to x dot shape, right? X that will work. So that should work right now. Now it should work.
D
Yes,
in first.
sir, it should be d. Yeah.
Now it should work, I guess. Yeah.
Yes, sir.
So you got some hyperplane, right? Okay.
Hello.
Now let's see that how that's. Yeah.
Sir, I have one doubt. Sir, actually, in this perceptron, but like if the data set is already linearly separable, then only it will like end. Otherwise, the loop will continue forever, right?
Yeah, correct. Because you already know. So that's the assumption that we make, right? For a perceptron to work, the most important assumption is what? The data set should be linearly separable. Then only the perceptron will work. Otherwise, we'll not be able to use the perceptron. For that, we'll have to use some other algorithm.
Yes, sir. Yes.
The most important assumption for the perceptron is
Sir,
the data
in the
set should
exam, sir, in the exam, if you give the data set, so first we have to check for the whether it's linearly separable, or are you going to give directly the linearly separable data set?
Yeah, it will be
In
given
okay.
linearly separable data only. Why will I trouble you by giving some?
Okay, sir.
Yeah.
Sir, just want to know like why we are. You said that y predictor is an array. So then, how you are comparing y predictor equals to 1 in for loop?
Where? Can you, which line you're talking about?
Fourth line in for loop, fifth line.
In the for loop, if y predicted is not equal to yi.
Y predicted is an array. So how you comparing y predicted with 1?
In which line you're talking
No,
about?
comparing means you say just below the for loop, sir.
Y predicted becomes an array after the for execution of the for loop. Before that, it's not an array.
Before that, it's not an array.
It's just a value
But
initially.
when it will enter second time, it will cause error.
No, we won't enter now. We are coming out of the loop, right?
So when it becomes array, y predicted.
Yes, sir. When entering second
No,
time in
I'm
for
not
loop.
getting whatever you are asking.
Let me explain you again. So can you see the for loop for I in range
Yeah.
n? Just below
Mhm.
that, a y predictor is there. So we are assigning y predictor equals to 1 or -1, right? But in the what do you say, if condition where we are comparing y predicted with y, either they are equal or not.
At
At
that
that
time,
time,
you're having some exact value, right? Y
uh,
predicted equals
at
to
that
1. If
at that
for
time y predicted is an array instead of 1 or 0.
no, in the starting, see, if you'll see that Y predicted goes to 1, if for some one data point, this is for one data point, but later what we are doing, this is for whole data set that you have. You're not, I guess now you are able to, so this is for one data point, ith data point, ith column.
Okay.
For ith column, if we are getting Y predicted equals to 1, this is fine. If Y predicted that we have got for the ith data point, so this is a one cycle. And after that, we came out of that cycle.
Okay. So y predictor is an array from starting itself.
No, starting you have
Yes,
some
sir.
value.
Sir. W NP dot 0 will be in array, right? 0, 0.
Which value?
So the initialization of W, when we initialize W dot 0, it will give us 0,
It is in the form of some
0.
vector. Yeah, it is in the form of a vector with 0, 0, like whatever the number of dimension you have. So it's a vector 0, 0 in the starting. Correct.
So y predictor is an array from this for loop itself, from the starting itself. You are means assuming that y predictor equals to 1 or -1.
Yeah, why? Yeah. So 1 and -1 that you are predicting. See, I'm
Uh-huh.
not able to.
See, if we are saying that y predicted is an array, then how can we get
So
like
see that
assign 1 or 0?
means okay. So here,
Sir, he is asking basically like,
huh?
sir, he's
What?
asking basically like after the so basically inside the for loop, y predicted is not an array, right? It's just a value which we are using to check
Because we are just
whether
checking for
the
1 point. Correct.
yes, and like once we come out of the for loop, we create an array for y predicted so that we can check it with
Yeah.
the
Because,
actual y like that we had for the
correct.
data
Correct.
set, right? So
Yeah.
basically inside the for loop, it's not an array, it's a single value which we are assigning it, like if w transpose x is equals to is greater than equals to 0 and -1 if it's not if it's less than 0, and then while execution after execution of the for loop, when we come out of the for loop, we create y predicted where we create an array out of it and check it with the actual y basically. So this is what is
Correct.
happening,
Correct.
I
This is
think.
what we are doing. Yeah. Yeah.
Okay, sir.
Yeah. See, in the starting, it was just a value that we are just giving for each of the data point. But later, we are checking for whole matrix. So now it becomes an array. Okay, and then we are comparing with the label that was also in the form of array also. I hope this is making
Okay, sir.
sense, right? We got a W
So,
also. Now let's try to visualize that
suppose
W.
if it takes, suppose it takes 5 iterations, so it will create an array, and then again the array will be deleted in the another loop, and then again it will create an array, right?
Which one? Y predicted?
Yes, why predicted?
It's
Y
in one
predicted
while
will
loop.
keep on changing. Yeah, that will keep on changing, right? See, after one loop that we have gone through each of the data point with one W. Let's for example, you have started with some W, and that W is also keep on updating. And after the 30, let's for example, you have a 20 data point. In the end, you got some W, right? And now you came out of that for loop, and now you have some W, some hyperplane. Okay, and if that
Right.
hyperplane is, because you have again with that hyperplane you have to check the y predicted, right? And that should match with the label. If it is not matching even for a one thing, again you have to go back to the label for loop and again do
For
the
loop,
same
yes.
thing. You got it, right? So y predicted will keep on changing according to your hyperplane. It will only be fixed once your convert, once you get this point, if it is like the predicted and the label is same, then if it is coming out of the while loop, then you can say that that hyperplane will always be giving the predicted and the label as same. Correct.
So it is dependent. So W is dependent on
W.
it is dependent on.
Yeah, it is dependent on W. Yeah, if the W will change, your value, your everything will change. Y predicted will change because Y predicted is what? If the W transpose X greater than equals to 0, it will predict as 1. If it is not, then it will predict as -1. This is what perceptron does, right? One statement. If one is condition, right? If it is satisfying this, it's fine. If it's not, then update the value of W and then come out and again check the value whether it is whatever the W that you have got, it is working for everything or every data point or not. If it is events not working for one data point, you have to do the same thing. I hope this is making sense. Let's move to the other part now. Let's visualize. Okay. Yeah, W will be in the form of array, right? And that will be having a two values. Like you can
Yes,
like
sir. So,
W.
sir, from the start itself, it's an array, right? Because that's where we are initializing. It's not that after coming out from loop, it's becoming array. Because if you see the type of W, you can see that it's array. We are
Yeah, it's an array
initializing the array.
because we
Yes,
have
you can
already
type.
given.
We can actually check, sir, here type of W.
But sir, why predicted when we do np dot where it is just converting into 1 or -1 based on the product w
Yeah,
cross
but
w.
this is for all the values of X, right? It's not for one value, one column.
That's
It's
why
for
it is
all the
making
column.
array.
Yeah, so that's why it is in the form of an array. So you can just check np dot where question mark, what does it return? So from there also you can get an idea. Okay.
Okay, we are getting array of like 1, -1, 1, something else, right?
And that you have to match. Otherwise, how will you
Okay.
match this? How will you match this Y predicted and Y?
Sir,
Okay.
can you print the Y predicted?
What?
Can you print the Y predicted?
Okay, let's do it. 1 second.
Your
Sir,
screen is not
inside the
visible.
for loop, inside the for loop and
Yeah.
outside the for loop also. Print both the Y predicted.
Your screen is not visible, sir. No.
1 second, 1 second. Is it visible now? Copy. Okay, this is what we're working on. See, okay, I'll just check it, but we. See, if you'll just check Y predicted. See, that will be same as Y. So there is no point of getting like confusion.
Inside the
Yeah.
for loop also, can you please print
For
just
loop
after Y
is.
predicted?
Before the for, so see.
Inside inside the for loop, just
No, sir, after the for loop. After the for loop, you can print, sir. Y
So for that
predicted
we have
array.
to run it again, like earlier.
okay.
So because now it should have stored Y predicted in the form of a whole array, right?
No, sir. That
Okay,
you can print before if condition.
this and all we can do it later also, but will tell you one thing. See, when it was in the for loop, you see what we are trying to do. Is this the whole matrix? This X, is it the whole matrix or one data point?
One
Data
column.
point. Correct. So if it's a one data point, how can it store a large number of values? No, right? So
No,
we
sir.
are already
No.
9:30, so we'll have to at least go through the SPM part also. So I'll just speed up. Is it
So
fine
you
or
can take more time
Yes,
today,
sir.
sir.
Yes, sir.
okay? So let's try to visualize this perceptron. Okay, how can you do that? How to visualize this? The same thing we can use it, right? Scatter plot that we have used. So with the same scatter plot, we'll have to do something else here. So where is that scatter plot? Okay, so here this we'll copy it here. Now we need to. Okay, how will you do that? How will you plot that hyperplane, this W? How will you plot this W? So I'll just try to write it one thing. See, our equation is what? This W will be in the form of what? W 0 times X 1 or whatever you want to write it, or maybe X plus W 1 times Y will be equal to 0. This is what W transpose X is. So if you can write it in the form of x1, y1 also, or x1, x2 also. This is the equation of a line, right? Line means hyperplane. Is this clear or not to everyone?
Yes, sir.
Yes, sir.
W1, x2. So if you have to write the equation in the form of a x2, because how do you plot? How do you plot a scatter plot or any plot? How do you do? You'll have to give x and y, correct? So x you can give directly in the form of x itself, that is independent. Because x, how will you give x? First of all, tell me. How did you in the first class we read it about in the matplotlib? Line space or something we read, right?
Yeah.
Correct. So x2 you can give directly as np dot line space. Correct, and anything you can give it as -5 to 5, and the default value it takes as 50. Now x2 should be what? X2 is what? X2 is our y, right? So what should be the equation from this equation? Can somebody tell me what should be the x2 value?
So minus W
not
0 divided by W1
into
W1
x1.
times x, correct? Times
Yes.
x. This should be the value. This, okay, let's plot it out then. PLT dot plot x comma, what should be the y? Y should be minus W, okay, upon W1, right? Times
How the X comes, sir, in the above?
Your
x.
x1 should be in numerators.
This you are asking?
No, above when we create X2, when we write X2 in form of like
X2, if
multiply,
you
we do
just
multiply in the end.
yeah, you just take this right side, right? If you'll just take
Yeah.
this right side, your x2 will become what? W of 0th index, okay, upon, sorry, this is
W1
x,
only.
right? This is x, this is x.
X.
X1.
Okay.
Okay, this is x1, right? And this is x1. This is our x1 is what? X basically. And x2 becomes y, right?
Okay,
So
X2 is Y. Okay.
x2 is y, right? So you can just write it in the form of xy or x1, x2.
Got it. Got
Clear?
it. Okay.
So this will become, I'll just put it a space so that it will be simple for you. Clear now?
You are not taking constant, right? Ax plus by plus c equals 0 like this.
No, we are not taking bias, right? I said you in the starting itself. We're just taking all the point which are just hyperplane is just passing through origin.
Okay, sir.
Okay, clear? And then we can give some color also. Let's example. Okay. Red or something. Red was the color. Red we have already gave, right? So we look like, what am I writing? So it should give something, right? Okay, you can see that, right? The hyperplane, correct? And this hyperplane is able to, okay, I'll just put it as black so that will be much clear. Is this hyperplane able to differentiate the blue, the green and the red, right?
So a small thing, if sir,
Huh?
there we are multiplying since the perceptron is converging on a value of W which is there. So what we are doing, we are constructing a line out of it by multiplying the first component of W to the first like the x1 component of a vector, like any point, the first component of that vector, and then multiplying the second component of W with the second component of that particular point. If I'm getting it
Correct.
correct.
If you have to do W
Okay.
transpose X, how do you write? One is row and one is column, right? If you
Yeah.
the row will become what? W1 and W2, like W0 or W1. W0 will get multiplied with X1 and W2 will get multiplied with X2. This is what it happens in the dot product, right?
Yes, 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 yes,
Are you able
yes,
to
yes,
understand
yes.
this, right?
Yes, 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 yes.
Yes, sir.
Okay.
Sir,
Yeah.
how this linspace is providing the elements of x?
This we have read, right, in the matplotlib. Like if we have to plot anything, if you have to, let's for example, if you have to plot y equals to x, so to plotting y equals to x, you need some data point, right? To need, at least you need
Yes.
2-3 data point, right? To need 2-3 data point, first you give x value, and corresponding to that x value you give y value, and then in the plotting, while plotting, you give x and y, then only you'll be able to plot. So for that we need some x value, right? Correct?
So from where we decided this X, sir?
X can be anything, right? It's an independent value, right? So independent value x, we can, according to x, this y will be there, right? If let's, for example, you are writing y equals to x as an equation, there x you can write anything, right? And depends on that x, y should also be equals to that value. If let's, for example, you are taking x equals to 1, then y should also be 1. And if you are taking x equals to 2, then y should be also equals to 2, right? Now in our case, I just took x as any random value from -5 to 5. That is like, basically we are taking 50 values. It's not written here, but by default we are taking 50 values of x between -5 to 5. Correct? And corresponding to that x value, we are able to calculate y value. And how are we calculating y? Y is equals to what? Minus w of, okay, so what is that? Minus the value we got, right? 14. So minus 14 upon minus 5 times x. Are you there? Are you able to understand this? I'm not able to write it. I'll have to join it from tablet. Then only I'll be able to write and show you. If you're
X
not able
is a
to,
simply numbers on the number line. It has nothing to do with the formula and all these things.
yeah, basically it's a simple thing, right?
Sir,
What,
it is a vector, and we are transposing it
okay, vector,
with the
it is a
W
form of
to
a
get
vector.
0.
That is fine. Vector has some
Okay.
value, some element, right?
But how the elements of that vectors are decided and taken, that I
Okay,
don't
see,
understand.
let's say example, you have any vector W transpose times x you write, correct? This is the equation that you write. This is the equation that you write. You're able to see my screen, right, everyone?
Yeah, yes, sir.
Okay. So how do you write this? You write in this form, right? Your W becomes, let's say example, will be a row vector or a column vector, anything. So you write it as W will be 1, right? W1 times x. You write x1, because x also will be having something x1, x2, correct? And also will be having w1, w2 if you are dealing with a two-dimensional values, correct?
Yeah.
Are you okay? Now, and this will be what? Plus w2 times x2, correct? Should be equals to 0, right? This will be the equation of the line or the hyperplane. Are you there?
Yes, yes.
Okay. Now you can write this x1. This x1 is what? One dimension. One dimension means what? One coordinate. In the xy coordinate, you can have this x as x1 and x2 as y, right? This is what I am writing. Your x2 becomes y, that is a dependent variable, and x1 becomes your independent variable. So depending upon the x1 value, if I am changing the x1, x2 should change, right?
Yeah, yeah.
Correct. So this is what I am doing. X2 equals to minus of w0, like w1 upon w2 times x1, that is x value. And then we have taken x ka value, some values, and depending x, I have plotted one line or the hyperplane. How did we plot? X, we have given the x value, and this is y value. That's it. You got
Okay,
it?
okay, sir.
So these weights are updated weights, right? Which we have calculated above.
Yeah, this is the final weight that we have got. This weight.
Okay.
This is the
Okay,
final
sir.
hyperplane. That's why we are getting the straight line, right? Like not the
Yeah.
hyperplane. If it is in a two dimension, that you can think of as a straight line itself. And you can see that this is converging, right? With converging, because you can see that it is able to differentiate, like the data set was
Yes, I got
linearly
it.
set. Yeah, got it right. Okay.
Yeah.
Can we move forward? Clear, right? Everything? Anything, any doubt
Yes,
that
sir.
you have for those cases also, you just put it in the group. If I'm like, I'll again check it and again tell you in the group itself. We have that group, right? Nobody's asking there. You can just ask there also, right? In the OPP, whatever the doubt that we have 2-3 more people. If I'll be doing mistake, somebody else will do, like, right? So that will be good, right? If you just post it there itself. Maybe after the meeting also, I'll try to describe this again, okay, in the chat, like in the G space. So no problem, because we are already 9:30. We have to go through. We haven't reached the hard margin itself. So okay, let's start with the hard margin now. So perceptron is clear, right? We got this. Let's, can you start the hard margin, the support vector machine?
Yes, sir.
Okay.
Yes,
So
sir.
in
Sure.
the support vector machine, what I said something. I said, okay, stop. I'll just show the again the same thing, the entire screen, and then yeah. Okay. So we have to solve this equation, correct? Are there able to see my screen?
Yes, sir.
Okay. So we have to solve this equation, right? So only this equation, right? We don't have to go here and there. Like all those things is fine. But at the end of the day, we have to just solve this equation and find that alpha. That is what we have to do. And for that also, particularly, this is a maximization problem, right? This is the equation. We have to maximize this and we have to find that alpha at which this function is getting maximized. For that, we already have a function. We already have a library in sci-fi. We have a library, like sci-fi is a library. In that, we have an attribute, or you can say the module minimize function that will minimize and give you the value at what value the function is getting maximized. So minimize, sorry. So if you have to maximize a function, you just take, what can you do? If you have to maximize the function fx, what should you do?
Just take the
Like
negative.
take the negative, right, to minimize the function. So in the sci-fi, we have a like a function to minimize it, okay, in that library. So we'll use that. Let's come here now. I'll just try to write. So where is copy? What was that? This only, right? This. Okay. You're able to see the screen now. So here I have to write. So we'll follow now for the dual of, because we are just dealing with a dual. We are not solving the primal. Primal dual will be getting the same thing. Now we have to compute y. We compute the object y that appears in the W. So this is y, right? How can I write this y? Y is what? Can somebody tell me how can I write the y? NP dot y is what? A matrix. At matrix with what? The diagonal element would be what? The label corresponding to the small y, right? Are you there?
Yes.
Yes.
Correct? If I'll just want to represent this, still the value, right? The diagonal value will be the label corresponding to y. What should be the, can somebody tell me what will be the shape of this y?
N into N.
And
N
into
into
N.
right? So 20 cross 20. That is done. Now, what is the step 2? And this is what will be asked in the OPP also. You will be given, okay, step 1, you have to write this. How will you write this? And you have to submit the Google Colab also. Okay. So this is what will be given, nothing else. In the next line, you have to define a function, right? How will you you have to define a function? Before that, I want to write what is this q. Okay, q I have to write. Okay, what is that q? Okay, from here you can take, this is q I am writing. So this is what? Y transpose x times y. Okay, let's write it out. Q, I'll just define it as what? Y. How can I take the transpose? Dot t, right? Correct?
Right. Right. Correct.
Times x dot t at the rate x at the rate y. Is this fine? You can see that, right? This is what has been written here. Y transpose xy. I wrote it. What should be the shape of Q? Can somebody tell me what should be the shape of Q? Just check it. This is 20 cross 20. This is what? 2 cross, sorry, 20 cross 2. 2 cross 20. Again 20 cross 20. What should be the value? 20 cross 20, right?
Yes, sir.
Okay. Now I'll have to write this function, right? This function only we have to maximize or minimize, whatever we, so this we have to minimize, because you can see that this is the negative. Okay, sorry, this function we have to maximize. So we'll have to take the negative of this function to minimize. Correct? Here it has been written. Here, this function we have to minimize. How can I write this function? We can define a function of f having this alpha Okay. What should I write? What should it return? It should return 0.5 times alpha
Alpha.
transpose, correct, at the rate q that we have already defined, times alpha. Okay. Now one thing. What should I write? Alpha transpose, and this is what? A column vector with all the values as 1. What should I write for this? Alpha transpose x. If you just multiply it, what should we get? What will you get? This is the alpha transpose is what? Alpha is for each of the data point, right? If you are just thinking as a row vector, because it will be in the form of 1 cross 20.
It will be just
Sum of
alpha
all the
trans.
alphas, correct?
Yes, yes.
Correct.
Yes,
So I
sir.
can write it like this: alpha dot sum. Fine. Is it fine to everyone?
Yes, sir.
Okay. So I'll just define it as it is. Now the next thing is what? I have to optimize this. For the optimization, what should I? I'll have to, from
Minim
sci-fi, I have to
minimize.
optimize. Optimize. What
Sir,
is that?
do we have to learn the formula of Q, sir? How did we find the Q?
Q here, right? Q is this one. Y transpose XY. Right? This is Q.
So once again, sir,
Just for the
please.
simplification, they could have written, I would have written Q as Y transpose XY also. Just for the simplification, I just wrote it Q so that you can directly define Q as it is. Now, inside Q, this is already been defined. What is Q? Y transpose XY. Okay? Is it clear?
Sir, can you show the formula once where it's there in the PDF?
Yeah, this is the formula.
Okay, sir. Okay, fine, sir. Thank you.
So it will be given in OP, this formula?
Yeah, this will be given. That formula, I'm not sure. But yeah, this will be given. Okay, even though I'll give
But
that also. Don't worry. That also I'll be giving.
okay, sir.
So all the formulas will be given for all other algorithms as well, or
No,
only
you will be
for
asked only the
SVM?
algorithm that we taught, nothing else. No algorithm will be asked like decision tree. No. Only SVM regression, I guess, has been taught and the K-mean. So there are only
But
three.
formula will be given for them. Like W transpose
Formula
X,
will be
Y.
given. Yeah, whatever will be described everything. Okay, and then you'll have to use just. You're not checking that you know the formula. You're just checking whether you are able to write the small things or not. That's it.
Okay, sir.
Okay. Now from sci-fi, optimize, we can import a function minimize itself. Minimize. Okay. And okay, what is that? Minimize. Okay. And then one more thing we have to import, that is bound. So we'll have to, whenever we are calculating or minimizing any function, some boundary we should be giving, right? From 0 to infinite or something. Okay. That also we have to import. So from sci-fi dot optimize, we have to import bound. Yeah. Okay. So now this is done. What should we do now? We have to minimize this function, right? This function f. So to minimize the function, we'll have to result. Result should be minimize this function f, correct? Okay, so let's first see. We first install this. We'll minimize this. We'll have to see. First import this. Okay. Okay, let's write it out. Result itself. Result or equals to. We have to minimize this function. Minimize this function f. Okay, see, you can see that f function I guess in this you have to first minimize the function. You'll have to give some initial value also. Some initial value you'll have to give in the form, or maybe you'll have to give something. I guess boundary though you have to give, because boundary I can remember boundary you'll have to give that boundary, because we have already imported the boundary, and that boundary will be from this. You can see that the boundary is what, 0 to infinite, any value you can take, right? So that will be 0 to np, then for infinite you use inf, right? Correct. And it's a iterative process, I guess, so you'll have to use, and if you are aware of this, is it a iterative, I guess you'll have to do something. Am I missing something?
Miss.
Sir, it says that we need some initial x naught, maybe somewhere to start, a starting point
Where is
maybe.
that? Okay, it's an iterative process, so you'll have to give something, some initial value. Let's, for example, x0 I'm giving out to be the np dot zeros itself, zeros of n.
So what is that if, sir?
What f?
So
K
comma.
will not come, sir, in zeros.
Sir, comma, you forgot a comma.
Minimize if.
Comma, sir.
Where?
After n, zero.
After np dot zeros.
Yeah, I guess that should work now. Okay, so let's check the result now. Yeah, you can see the result now. Okay, so result has what? The function, this is converged. Okay, and then you have got some function value also. So minus 4.99 is the minimum value. Okay, at what point that also you got? You can see the x value, right? Okay, so this is the point at which the function got minimized. So let's check that value itself. Result dot x, right? So this is the value. You can see the value, right? Correct. This is what, this value you got, right? At this particular value, you are getting the you are minimizing the function, right? This is what, this is basically what, your alpha star, correct, at which the function is getting minimized. If you just want to print this also, alpha star, what is that error?
It should be
Sir,
alpha
we
star
should
equals to
the
this only.
alpha star equal.
Okay, you got it right. Now we have the alpha star, right, at which, at that particular, so now we were searching for that alpha, correct? We got that alpha. Okay, so we have solved this function. Now we have that alpha. Now can somebody tell me how many of this value are basically will be in your support vector machine, like the supporting vector, where your alpha star is what, greater than 0, correct?
Right.
6.
6, sir.
Right. So
Yes.
1, 2, 3, 4, 5, 6. So 6 values are there. Yeah. So this type of problem can be asked. So you'll have to solve this and then tell the number of supporting vectors. So this you can calculate it, right? Or you, if you are able to plot it also, you'll be able to get it. So now we got it. Let us find all the support vector. You can see that. Can somebody asking something? Yeah, Ravi, you're
Sir,
asking
can you
something.
go to the code? Yes, sir. Sir, can you go to the code once? Sir, can you go to the code once?
Once. Here?
No, above.
Okay.
Yeah, here. Sir, here minimize of if, how, where it is if, sir, where we have defined.
Here, right? We have defined a function f.
Okay, we are calling the function.
Yeah. We are defining a function, okay, with alpha f, this function itself. Alpha times alpha transpose q, alpha minus alpha. This is the function, and this function we are minimizing, right?
Okay, fine.
And so you have done alpha dot sum instead of 1. There alpha into 1.
This is alpha and not this is a column vector with all the element as one. So if you have a column vector and a row vector, right? So how do
Huh.
you do? You just multiply, right? Alpha 1 times 1 plus alpha 2 times 2 1 plus alpha 3 times 1, right? So that is basically what the summation of all the element of alpha. This is what I have done, right?
Okay,
Where
alpha transpose means all the alphas. Alpha transpose means.
alpha transpose means it's a row vector, right? With all the alphas, like corresponding
Yeah.
to each of the data point.
Yeah, same thing we'll do with weight vectors also. W
Ha ha.
transpose.
Yeah, yeah.
Got got.
Okay.
Sir, in
Now,
the second code block, we are actually getting the optimal value from using SciPy, and in the first one, it's the user defined, right?
where
Define alpha.
this,
This
yeah,
is
this
yes.
function we have defined first. This
Which
function we
yes.
are giving to a function, minimize function, that will minimize this function and give us the final value. See, one thing we are not doing it here is minimizing the function. We have some function, minimize function, that is inside sci-fi optimize. Okay, that is working for us to give the minimization of whatever the function that we have defined. We have defined
Yes,
the
sir, I
function.
understood that. So
Yeah,
what
okay.
I'm saying is the one that we have defined here, we are not using because SciPy is we are just using the SciPy library,
No,
right?
we are
In
using this
this.
function, right? Whatever we have defined. We have defined this f
But sir,
function, right?
where I do not see where it's
Here,
being
here,
used.
here, here. You can see the function f,
Oh,
right?
okay. F. Oh, okay, sir. Yes, sir. I saw. Okay, okay. I see now.
Okay.
Okay, so thank you.
Okay. Without giving the function, how will we know that what are the
Yes,
values that?
that's why, sir. I was wondering that whether it's a implicit in SciPy library or
Huh, huh.
how that's being done. Okay, understood, sir. Thank you.
Okay, okay. Okay, so where we okay, we went here. Now we have everything. So now let us find all the support vector. Recall that support vector are those points for which alpha i's are 0. So what should I do? You will have to tell me what should I do. How should I get all the vectors? So we can see that there are three vectors, right? Which are support vector. Now I'll have to find which are those vector.
np dot where maybe we can use.
Np dot where and what should I do?
Maybe uh, we can get a array of zeros and ones where it is
No,
zero.
what will the condition that you'll apply?
uh, that xi is greater than 0 or
Can we do
alpha
it?
star I is greater than 0 maybe.
Okay. Can we do it like this? X. We need the vectors, right? We need the vectors, right? See, if you'll use it np dot where, but what is the condition that will apply? What will you apply? Alpha star greater than 0?
Right.
But what should it return to you? It should
It
return
will
what?
give me boolean values, I guess, or whatever values that I ask him or
It
ask
will
it.
give you the boolean. Okay, but okay. One thing you can do,
Sir,
and
where alpha is greater than 0, we can take that column from the X vector, X matrix and get the vectors.
that also you can do. Yeah, whatever you're
Sir,
saying. But
we
Yeah,
need
X.
array.
Hmm.
alpha star greater than 0. Correct? This should give me, right?
Sir,
Some.
we should
Yeah, yeah.
yeah,
This
yeah.
is given us, right? 2, 5, 1, 2. These are the vectors, or you can say the data points. I guess the sixth data point, if you'll just check it, let's check it. If you just, what was the sixth one? Yeah, this is the one, right? 2, comma 5, for which the alpha was greater than 0. So we got those data set, right? So all the rows, we don't have to worry about the rows. So we need all those data points where alpha star is greater than 0, correct?
Yeah, correct.
Correct. Okay. So now we have all the 6 support vectors. Now we'll have to show that also, right? How will you show that? Okay, in the primal solution, what is the W? W, how do you calculate W? W, you know, right? W is pretty simple, right? How do you calculate
X, Y, L, alpha.
X, Y, alpha, correct? Yeah. So whoever has said, it's totally correct. If you have to W star or the final W, if so this W star that we are calculating is from the support vector machine. Okay, and that should be what? X times Y times what should be the value? Alpha star, right? Alpha that we have got a star. This should give me, right, the W star. Yeah, we got a W, right? This is corresponding to our SVM, support vector machine route. Now we'll have to plot it. How will you plot this? We can again use the same thing, right? Again from the upper part wherever we were here. So here also we'll use the same thing. The other part will change it. Okay, what should I write now? I'll have to plot it. What? I'll have to plot now. PLT dot plot. What should I give the X and Y axis? Again the same thing, right? Same thing I'll do. Either
Linspace X will be no.
X I have to give X equals to NP dot line space. Again -5 to 5 I can give. Now X I can give the same thing, right? X as X. And Y should be what? The same thing I will write. In spite of W, I can just directly write W star, right? Where is that? This is what, okay. The same thing I should write. Only the W star I have to write. Oh, what? Okay. This should be W star. This also should be W star. I guess this should give us, correct?
Yes, sir.
Got it, right? If you want to, if you are not able to differentiate between these two, okay, I'll just put it as which color? Yellow. Can you see the difference between these two? One is the yellow one is because of perceptron. The other one is the support vector SB hard margin SVM. Can you see this?
Yes, sir.
Sir, how are we getting two lines?
One is yellow is because of the perceptron.
Okay.
We are using different algorithm. If you are using different algorithm, you'll be getting different hyperplane, right? That will separate your. So that's why we have a number of classification algorithm, right? If you're using something else, maybe the logistic will be getting a different hyperplane. Okay.
Sir, what's the margin that we use here?
Okay, let's calculate the margin also. Okay. How will you calculate the margin? Okay, let's write it here itself. How do you write the margin? For any function, how do you write? The margin, so there in those cases, W1 times X1 plus W2 times X2 becomes what? Equals to -1 or 1, right? Correct? Are you there with me or not?
Yes, sir.
Okay, so see the early, so the hyperplane was what? Your hyperplane was where this was equals to 0. But your supporting hyperplane will be equals to 1 or -1, correct? This will be 1 or -1. Are there or not? Now,
yes, sir.
I'll have to plot, if I have to plot the hyperplane also, what should I do? I'll just have to do what? I'll have to change y. What will be y? For this condition, our x2 was what? X2 was, okay. X2 was minus of W1 times X1, sorry, W1, okay, upon W2. Correct? This was our X2. Now for this case, what will be the value of X2? Tell me, what will be the value of X2 for this case? Tell me, somebody tell me. You just have to do shift right, left, and
1 minus W1.
W1
1 upon W2, correct?
into X2 into X2.
Why? See,
Sorry, sir.
no, 1,
Sorry, sorry.
1 upon W2 minus W1 upon W2 times X2, correct?
Yes, sir.
Is it clear to everyone? Is it clear to everyone?
X1, I guess, no? Because
Where?
we are finding X2.
X1,
We are
X1.
finding X.
Yes, sir.
Oh, yeah. Now let's plot it out. Then now we don't have any issue. Okay, I already copied it, right? So now what will be the y value? X is fine. Y we just have to change, right? Y will be this equation, correct? So we'll have to add something. 1 plus 1 upon W star, correct? Times 1. I guess that will suffice. Anything that we are missing out? That should work, right? And
Yes.
same,
And it's a red color.
we can give color different. Sorry, why? How many times? Okay, one thing. One I can just put minus. This minus will give you the other hyperplane. Okay, let's try it out. What should we get? Yeah. So yellow one, I'll just for some time. Perceptron, I'll just remove. No, God. You can see this, right? So how many support vector are there? The 1, 2, 3, 4. 4 from the green side and 2 from the red side. And you can see the margin also, right? Can you see the margin?
Yes, sir.
Okay. So
Sir,
this
how four support vectors are there? Like
4 from the green side and 2 from the red side. So altogether 6, right?
I didn't get that, sir.
So only 2 support vectors are there, right?
See, this is 1.
Okay.
This 2, 3. You can see my arrow, right? Arrow.
Yeah, arrow. I can see that.
Okay.
1, 2, 3, 4, right? 5,
Okay.
6.
Oh, I got that.
Everyone got it, right?
Yes.
Okay. I hope this is clear. Now let's move to the soft SPM. There's very less people. Everyone went. Okay. So let's start with the soft. Okay. For the soft SPM, what else we have to do? We just have to only one thing. What was that?
Add. We
In
have
the
to add
dual
that.
problem. Yeah. Go ahead.
No, sir. Okay.
Yeah. In the dual problem, only thing condition was alpha should be from 0 to C, nothing else, right? If you'll just see that. Yeah. So now in the soft SVM, what happened? The soft margin, what happened? Only the extra things that comes in is the C that you will be giving. So okay, and from where that C came, I hope you are already aware, because in the soft margin SVM, in the optimization problem, or you can say in the objective problem itself, you will be having two things, right? One hinge loss and one the thing that you have to minimize, the W square upon 2, correct? I hope if you remember this function, right? There is two things, right? One is minimization of the W square upon 2, and you have added one zeta. Zeta is what? The penalty that you. So whichever data point which are lying on the wrong side has to give some penalty and will go to the correct side, right? This is the penalty that we are introducing. And to pay the penalty also, and there is some payment for the penalty also. If somebody has to give the penalty, for that also there is some payment that he has to pay, because if there is no C condition, that if C was not there, everybody would have given the penalty and then would have went to the correct direction, and then the answer would have been 0, like, because you already know that if you have to minimize some W, 0 can be the best solution, right? Because we can directly see that 0 can be the solution if you just have to minimize W square upon 2 for each of the conditions. So that's why we have two things that you have to balance. One is the objective function and the other is the hinge loss that you have to balance it. Okay, so the C becomes very important here to balance it. Okay, we'll see that depending upon the C, how does the margin changes. So can somebody tell me how does the value of C will impact the margin?
Uh,
So
How
they
does
are
that?
inversely proportional, I guess.
Higher
Okay,
C
let's
lower
assume.
the margin.
Okay.
high values would.
If C is 0, then it is a hard margin problem again. And if we increase C,
No, C, whenever the C is infinite, then becomes a hard margin. Why? Because you are giving too much importance just to penalty. That means you don't have to, you can't pay bribe and go to the correct direction. That means it becomes a hard margin. Okay, and whenever the C becomes very zero, like very less, okay, that means what? We are giving more importance to just minimization of this function itself. Okay, are you getting me? Are you get okay? So see,
Yes, sir.
just one thing you should have to remember: if the C is very less, the margin will become high or low.
Low, sir.
High.
Margin will be high, right? Because if the C value is very less, that means what? We are giving more importance to the objective function, the first part. That means you have to minimize this function. Minimization of W means what? Your margin is getting larger, because W, the margin is what? The length of margin is what? 1 upon W or 2 upon W, whatever you want to call. Correct? So if you are minimizing this function, that means minimizing your W, that means 1 upon W becomes larger. That means the margin will become as large as possible. Correct? Okay, let's. Okay, so if you have forgotten the concept, okay, no problem, but we'll try to just put it in the form
Uh,
of code.
so
Yeah.
one so 1 upon W is a width only, right? Width
Yeah,
formula.
1 upon W is a width. So if we are minimizing W square, any function, okay, that
Huh.
means we are minimizing that W. If minimizing that W means 1 upon W will be as large as possible, right?
As large as possible. It means
Correct.
width is greater, margin is greater.
Width is greater.
One upon W, if it's large value, then
The
it means
margin
that
is
width.
large. Yeah.
Then it means width is greater. Width means margin only.
Yeah, that is larger. So whenever the C is less, the margin
Huh.
becomes more.
Yeah.
Huh. And whenever the C becomes very high, that becomes you are just tending toward a hard margin C, because you are giving more importance just to the bribe. You don't have to pay the bribe. To pay the bribe itself, you have to pay a lot of C. Like the C is what? C is some value that you have kept. Otherwise, everybody was paying the bribe and going to the right direction. So to just counter that, you have given some C. Correct?
Yeah.
And if C becomes very high, that means to pay the bribe, that penalty is very high. So nobody will pay that. So that means again you are moving towards the hard margin. Got it right?
Yes, sir. Sir, in hard margin, like the margin will be very high, or
No, so that you can't compare, right? With this is like a like how will you compare the margin with the soft one with the hard one? The
We don't
margin,
have
the
any
width will
errors.
be small as possible if you are just increasing the C value as larger. You see, that will if you are just taking then the impurity, so many things gets involved. If your C is very less, that means what? You're just giving importance to the other part. You're not giving importance to the number of errors that is happening. That means the number of errors, your algorithm will start making a lot of mistakes. So you'll have to just counter this two, because this both work like the first objective function, the first part and the second part both work in opposite direction. So you'll have to just counter this C and get a better C. That is what you have to do.
So,
Okay.
like suppose if C gets infinite, so our problems will be hard margin problem.
Your problem will become tending toward a hard margin. Correct.
And the margin will be like will be more or less.
Less, the margin will be as low as possible, because you are not caring about the first part. C is infinite means what? If you see the two equation, if C becomes very high, that means what? You are just giving importance to the second part. That means you are just giving importance that the error should be as less as possible. That means if the error to be as less as possible, you are just reducing your margin. If you are just reducing the margin, the error will be as less as possible, right? You can see that in the fourth diagram.
So from the graph itself, we see, right, its margin
Correct.
is shrinking when we are
Correct.
increasing C.
Whenever the margin is shrinking, then this model is making less mistake as compared to the other one. In the first margin, when the C1 is much lesser, 0.01, you can see that there is a lot of mistake that is this algorithm has made. But in the fourth diagram, you can see that it has made a very less mistakes. But then you have to counter both, because again this is also not that good, because if your data point, because this will work better when you just have a linearly separable data. If you are getting some data set that are in the opposite direction, then if you're just dealing with C equals to infinite, that will not work. So you'll have to just counter it somehow. Okay, let's move. So we'll not be discussing much theory about that. We'll start to solve this equation. So nothing much. I'll just write the whole code. We just have to copy paste, because nothing else we'll have to do. We just have to put while solving that minimization problem. We just have to do some. Okay, I'll just let's define it as so. What Q and all we already have, so I'll just take it everything from the up. So I'll just write it itself. Let's define this. We'll train a SVM. Well, we'll be giving X, will give Y, and will give C. Everything else we can just write it from the up. D gross and Y was what? NP dot diagonal of Y. Q was Q. I already wrote it somewhere. What else? After Q, we have defined what? We have defined the function. The function will also be same. What else? We have just given the shape. Y is also diagonal Q.
It's a function. Written in the.
Okay, 1 second. I'll just go through the where the function was written. The dual was written somewhere, right? Oh. What did you say?
It's a return statement, that error.
Okay, that's true. What is the error? Oh,
In
sorry.
indentation.
I guess it's fine now. Okay, so now we'll have to result. What was the result? Result was equals to minimize the function. Same thing. Where is that sci-fi? Only thing is we'll have to give the foundation. The foundation should be zero because we are just dealing with the soft measure. Okay. Same thing. Alpha star will be what? Result dot x. Correct. What else?
Sir, in the previous one, the bound was infinity.
But in this case, will be bound when we see, right?
Okay, fine.
Okay, I guess if you know that or not, the lectures, if you just go through the lectures, uh, you have that foundation, right? That alpha plus beta becomes C, and then the foundation of this alpha
Yeah,
is
yeah.
C only. You will not be taking anything else. Okay. I hope if you don't remember, you can just go through the topics. I guess. What else? What else? W star. After this, we have W star also. Got it right? Now the support vector you can just think of as same thing where alpha star is greater than 0. Then what should it return? It should return the alpha star, and what W star it should return. We are giving input X, Y, C, so it should return W star also it should return and the support vector it should return. I hope. Okay. Now let's plot it out. So if we want to get the W star just call it out, or maybe let's plot it out first. This is clear, right? So same thing we are doing. Only the foundation that we are fixing is from 0 to 6, 0 to C. Okay, clear?
Yes, sir.
Okay. So now, and the plot also, whatever we'll be plotting, we'll plotting the same thing, right? So again, plot also you'll have to copy everything. Okay, let's copy it. So again, what is this PLT dot scatter? What is that? X will be 1 second. I have to go somewhere. Okay, let's finish it out quickly. So we can just copy it. The plot, where is that? This one only, right? But this also I can just define it in the function itself. So here we'll just plot and we'll give something inside. We'll give capital X, capital Y, W star. What else? What else? What else? I'll have to define X also. X. Are you there? Are you able to get it right? So these are all just copy paste, nothing else we are doing.
NP dot line space. NP.
And okay, NP. Okay, then the same thing, right? The same thing we can copy. Where is that? All these three things will be same. Okay, I would have copied it from here itself. All the three things will be same.
So we can finish it fast so that you can do your work like.
So this is a right. Anything else? We can just this will give us the correct thing, right? Only thing is, yeah, this is done right. If you are just giving x y w star support vector, c also I'll have to give, right? Let's see what it gives. Okay, now so we have defined it. One plot is there. If you are giving x y w star support vector c, it should do something, and here also we have trained. Okay, now I have to give c value. 4 c values are there, right? I'll have to give this is 4 values. Okay, let's write out the first thing. Okay, let's try it out. Alpha star. What was the other thing? Alpha star, W star, right? Alpha star, W star, and then support. What was that? Support vector equals to, we were calling train SVM. Call it right. Correct. And then it should plot also. It should plot PLFT plot C value I'm just giving as first. Okay, so I'll have to plot for 4 thing, right? I can use subplot, right? Subplot I can use LD dot subplot 2 cross whatever. This example, this is 1. So for this case, C value is 0.01. Correct. Plot XY W star, what is support vector then 0.0. So this should give
So
me
there is a typo. There's a subvector P.
okay, it should be sub vector, right? Should be P only. P only I wrote, right? Everywhere.
Yeah, below sir.
In the next
Data.
line.
Yeah.
Dot.
Okay, that's done, right? Similarly, you can do it for the other cases also. So this should be second. What was that? 0.1. This is 1 and 10. 1, 10. I guess that should work.
So subplot for PLT dot subplot.
Correct? We can use this also. Fig size, right? What is that? Fig size. Figure dot fig size or something. Figure dot fig size.
So what does RC params do?
It's just to change the size and all of the picture that you are getting. It is small, right? That's why I'm just changing it. It should be equals to some, let's say example. Maybe put it like 8,8. Let's check it. Okay. This we are getting, right? Yeah, you can see that, right? The first one was having what? Much less, right? That is what we thought of. that the margin will be very high. Second case, the margin is lesser because C was decreasing, sorry, increasing. The third case, much more, and the last one, much more. Okay, that becomes a hard margin itself. You can see that, right? The same data set, almost 6 support vector. I guess this clear, right? Everyone?
Right, sir. Could you just show the code once, just as right, sir? Okay.
Okay, right? Anyone has any doubt? So I guess there is only one doubt that was related to why we predicted that. I'll discuss in the G space again. I'll go through the code again and I'll discuss with you. Okay. Other than that,
Yes,
any
sir.
that you faced in any of the line, I don't think so. There is that difficult. Like mostly we were having some equation, maths equation, and we were having sci-fi to solve our equation, and then we got everything. Correct?
Yes, sir.
Hmm. Any doubt anybody has? And this is type of problem. So I'll just show you one assignment also if you want to. I'll just show you one assignment. I'll just first stop sharing and then I'll show you one assignment. And this type of problem will be asked in their examination. So
Sir, is it possible to share the collab we did just now?
I'll share it. I'll upload it that, right? There is a folder like solution that will be putting up, whatever the folder that we have shared it in the G space. There, all the collab that we have solved during the session will be shared there. Okay. I guess
And
three,
sir,
like till day 3, everything has been shared. Day 4, I'll be sharing after the session. Okay.
please share the videos of the previous sessions as well.
Yeah, sure. Yeah, this type of assignments will be asked in the exam.
Sir, please upload and share it if possible.
You got it idea, right? So see, you have been given problem 1. The first one is you write the x is the data. What is the value of x, n, and d? You'll have to put it on the. So I just gave you an idea, total idea itself, and this type of problem will be given in the exam. So you'll have to. I hope you'll
Sir,
be
how
able to.
many questions? Sir, how many questions
Around
in
20
total?
questions will be there. 20 questions will be there. Yeah, so visualize the data set. So whatever we have done, so whatever we are doing now, the same thing will be asked. Nothing more, nothing less. Okay. Compute the y appears in the dual problem. Okay, so here the equation. So you can just, I'll just try to give the equation also. But if I'll just give the equation, y will be able to write like will okay, but we'll try to give as much as function like equation also, because we'll just be giving 3. We have just discussed one regression, one clustering, and one classification. So this 3, that is not that difficult to remember also, and you don't have much formula in the other linear regression you have, but SVM mostly you have this formula only. So okay, but we'll try to give it in. So here also you can see that compute the object y that appears in the dual. So these all things will be, so this type of problem will be asked in the exam. Okay. Find all the support vector, print indices and all. Okay. And this indices you have to write it in your portal. So this type of problem will be asked in the exam. I hope this is clear to everyone. Okay.
So we don't have to plot any graph or anything like no in the
If
exam.
most probably will not be asked to plot as such. Okay, one thing I'm just getting a call. Okay, just 5 minutes. Okay, life optimization.
Okay, we are done. So you can like do your work.
Sir, there is plot. Last question. Problem 9.
Where?
Problem 9, sir. 9. Problem 9.
Upload along with the no, they're asking, so you'll have to write how many green points. So without, so the problem in such a way that without plotting you'll not be able to write the answer. So mostly the answer they'll be asking, like the number of support vector. If you are able to do it without even writing it, without even plotting it, then it's well and good. But it's better you plot it. So here it has been asked how many green points line of support. You
Okay.
can do it without even plotting also. How will you do that? You already know that we used
Using, yes, sir, those
right?
formulas, right?
From indexing, you can just check which index, and then if you have an idea which of the points were the starting 10 points was one green or the
Great.
last one red. So from there you can get an idea. But with the plot, you'll be like there won't be any mistake. That
Yeah,
is
but they may ask like how many points lie on this line. over this line. That can also ask. Like support vector.
Uh-huh.
Like six, we have discussed that six support vectors are there, four green and two red. They may also ask like this.
Yeah, they can ask like that. Yeah, correct.
Yeah. So for that graph is needed. Without graph, not possible.
Yeah, without that, that will be difficult. But even though without, also it can be. But okay.
Yeah, because there were many red and green points are there, but only 6 points lying on the four green and two red over
Huh.
that line support
Yeah,
vector.
yeah.
So that's the thing.
Actually, sir, we can calculate that using the formula because W transpose X is equal to will be 0 for the ones which are exactly lying on the boundaries, and for the other ones it will be greater or less for the different classes. But it will be tedious process actually to
Correct. So it's better
compute
to.
using
But the
formula.
plotting was much
Yeah,
easier, right? The plotting is not that difficult. At least in today's session, the plotting was not that difficult, right? It was all simple plot.
it needs actually some practice, I think.
Okay.
Sir, if we practice these things correctly, then how good we become in machine learning engineering and all can become like.
See, ML engineering is like, see, there is a like, yeah, data science is like totally you're using just a library. In the
Yeah.
engineering, you're just making those libraries, some of the libraries. Okay.
Hmm.
So I
So
guess,
machine
yeah.
learning related job, machine learning engineer, like that.
Yeah, this is what I'm saying. So MLP, have you done MLP? No. Huh?
No, sir.
Okay. So when you'll go through the MLP, then you'll feel like these are all very simple because everything you're doing with the help of the libraries, right? All the
Oh,
libraries have been already made. Okay. You just have to, for SBM, you don't have to write this many codes. You just have to sklearn libraries there. From there, you just have to import the SVM. That's it. Nothing else. So there's one line of code.
okay, sir. Got
Yeah.
it, sir.
So, but the later phase, the most problematic thing is the data, the unstructured data that you are getting, that you have to structure in a good way. So that becomes the starting part becomes very difficult. Using algo and all is very simple. The much easier, the very easiest thing. Only the most important part is the EDA. Okay,
Structure,
data analysis.
structuring the data.
Yeah, correct.
Oh,
The starting portion only is the most important. Other part is pretty simple. That you'll come to know here, because this is the course that does the whole maths behind all the algorithm. I don't think so most of the people even know. Whoever is working in the data science, I can tell you, like, most of the people even doesn't know like how does SBM work,
because,
what is the assumption that SBM made. We just have the library and then they're just using it on any data set. After some time, even we start forgetting because we are in the touch,
mm,
we are just learning, so we have that idea. But after some time, even we will forget, okay, which algorithm was working on which data set. Okay, let's use it the whole. You have one line of code for each of the algorithm. We'll try to use it all the algorithm and then check, okay, on which of them this is working pretty fine, and we'll go with that algo. Okay, so this is how it works.
okay. Okay. Thank you very much, sir.
Okay. Okay, thanks everyone. And the doubt that you have, even I'll just check it. If I'm wrong, I'll just clarify in the G space. Okay.
Why predicted one?
Thank you, sir. Good night.
Yeah.
So while just checking the G space, I will be able to access all the like collabs
Correct,
that
correct. Yeah.
have been
And
created.
yeah, yeah. Any doubt you can just put it on the G space. Any other session also, if you want any doubt session or anything, you just put it there. We'll try to sort it out. We can have one more session before the OPP also as a doubt session. Okay.
Got it, got it, got it.
Okay.
Also, mm, in the CS2007 YouTube channel, I think the live sessions are already being broadcasted. I think
Yeah,
either
it
the
was
live.
there. I just made it private, but it will be again public maybe by
Okay,
tomorrow. Okay. Yeah.
okay, okay.
Recording will be provided just like after the session itself. I'll upload it on the drive and share it in the group. Any doubt, you just post it there with the screenshot or however you want to. Maybe mail me or like not mail me, but yeah, in the G space itself you can put it. Some or other will reply. If no one will reply, I'll try to reply. Okay. We have some more people also here. So my mail ID is vishal@study.iitm.ac.in. It's like same as just write vishal@study. That's yours. Hmm.
Okay.
Sir, can I ask a question?
Yeah.
Sir, like the OPP date is planned, scheduled for 26th, 25th or 26th?
Most probably, but yeah, that
Okay.
is the thing. Yeah.
Okay. So like, and then would there be any practice assignments that we'll be having?
I'll try to give, but I can't promise it. One or two I can give you, but I can't, because
Okay.
whatever we are making, that will come in the exam itself. So there's no,
Okay.
whatever we are doing it in the collab will come in the exam. So there is no point of, but okay, if you try, I can just give you the assignment. Yeah.
And that will be helpful, sir. Yeah. Thank you so much.
Thanks everyone, and have a wonderful.
Thank you, sir. Good night, sir.
Thanks.
Thank you, sir.
Thank you so much.
Thank you.
Thank you.
Thanks a lot, sir. Thank you.
Thank you.